सर जो लास्ट में आप करवाए थे, फिर इसमें यही नहीं समझ पा रहा हूँ कि आई आई टू का स्क्वायर थीटा, सर उसको साइन स्क्वायर टू थीटा में कैसे कन्वर्ट किए थे आप?
Hmm. I have used this formula. देखो cos theta, cos theta is sorry 2 cos square theta by 2 minus 1. ठीक है ना? This is one of the second
Yes, sir.
formula for cos theta is 1 minus 2 sin square theta by 2. ठीक है? So I have used this formula. What was there? Can you tell me how much 2 cos square? What was there? 2 cos square, 2 sin square. I don't remember.
सर वहाँ पर सर वहाँ पर था आई नॉट बाई टू कास
Just
स्क्वायर थीटा माइनस।
I check it. I don't remember like this.
यस
Just
सर।
give me a minute.
ओके सर।
If I'm not wrong, this is I naught by 8 sin square 2 theta. ठीक है?
यस
So
सर। सर यही कैसे आया था, आई नॉट बाई एट साइन स्क्वायर टू थीटा कैसे आया था?
that was I naught by 2 first.
यस सर।
Cos square theta was there,
यस सर।
and cos square 90 minus theta was there. I think this was the earlier expression, if I'm not wrong. We were having something like this. So what is cos 90 minus theta? Cos 90 minus theta is cos 90 minus theta.
Sin theta.
That will be sin theta. Correct. Button. So here I write it as I naught by 2 cos square theta, and this will be sin square theta. ठीक
सर
है? Yes.
सर फार्मूला तो इतना ही है ना कि आई नॉट बाई टू कॉस स्क्वायर थीटा, तो सर ये अगला वाला टर्म कैसे आ गया, कॉस स्क्वायर 90 माइनस थीटा?
Okay. Okay. So here you are having three polarizers. First polarizer is this.
यस
Second
सर।
polar, forget that question. I'm simplifying that one. This is
यस सर।
second. This is third polarizer.
यस
P1,
सर।
P2, P3. Forget the rotation. You just have three polarizers. And path axis of P1 is perpendicular to the path axis of P3. ठीक है?
यस सर।
So I can make even much better diagram for you so that you can understand. So this is first polarizer like this. This is first polarizer, and I'm saying its path axis is this. I'm just assuming this is P1, and I'm calling this direction as theta equal to 0.
यस सर।
Second polarizer is here. This is second polarizer, and its path axis is like this. ठीक है? So this is the path axis. ये जो this line, ये जो dark line is representing the path axis. So what is the angle between this and this? That will be 90 degree. Easily you can write what will be theta for this. Theta is 90 degree.
यस सर।
So if you are assuming this direction is 0, then if I make it perpendicular in perpendicular direction, this will be 90 degree. ठीक है ना? This will be 90 degree.
यस
Now,
सर।
in between these two, there is one more polarizer. And this, I'm saying this is P2. In between these two, you place a polarizer that is P3. And where is its path axis? Its path axis is somewhere else. This is not the path axis. Its path axis is suppose like this. This is the path axis. It is making theta angle with this. ठीक है ना, here this is 0, so this angle will be theta. So what is here? This angle path axis is at an angle theta. ठीक है,
yes
this is
sir,
the path axis direction. Now unpolarized light is incident from this side. This is unpolarized light whose intensity is I naught. So when it will pass through it, when it will emerge from here,
sir
ठीक है
I
ना,
naught by 2, yes sir,
this will be, it will
I
have
naught,
electric vectors parallel to this.
yes sir,
And this will be a plane polarized light.
yes sir,
Plane polarized light. I'm saying its intensity is I1.
yes sir,
So what will be I1? That will
I
be
naught
I
by 2,
naught by 2.
yes sir,
ठीक है? Now, these electric vectors, they're falling like this. Where will be these electric vectors? These electric vectors will be in this direction.
yes sir,
ठीक है ना? So these electric vectors, they will be like this. This is the path axis. So what is the angle between these two? Theta.
theta,
So when
yes,
light will emerge from here, from this polarizer, okay, now when light is going to emerge from this polarizer, it will be plane polarized again.
yes sir,
But now electric vector will be parallel to this path axis. Their direction will be like this. These electric vectors, they are not tilted, they are parallel to this. ठीक है ना? These electric vectors, they are perpendicular to this direction, but they are a little bit tilted and they are parallel to the path axis of this mid one
yes sir,
polarizer. They are like this. ठीक है? So now where they will fall here. They will fall like this. These are the electric vectors when they are falling over here. Now what will be the angle between this electric vector and this path axis? This angle is theta. So automatically this angle will be 90 minus theta. 90. So first here I1 is I naught by 2. Here intensity will be I2. So what will be the intensity I2? Here
sir
incident
I naught
intensity
by
is
2
I1.
cos square theta,
So I2 will be I1,
yes sir, cos square theta,
I1, and this will be cos square theta.
yes sir,
Now this intensity I2 is falling on it, and angle between the electric vector and this path axis is 90 minus theta. So when light will emerge from here, try to understand, when light is emerged from here, it will be plane polarized light and its electric vector will be like this, parallel
yes
to
sir,
this line.
yes sir,
They are perpendicular. These electric vectors, they are perpendicular to this direction. So don't confuse. So
yes sir,
these electric vectors, they are still perpendicular to this direction, k direction. Okay, so they are like this. And what will be intensity? That will be I2. I3, you can say. What will be I3? I3 will be incident intensity is I2 cos square. And here angle will be angle between the electric vector and the path axis, that is 90 minus theta.
yes sir,
And how much cost 90 minus theta? That will be sine
sin
theta.
theta,
So I make it sine square theta. Now
yes,
substitute the value of I2. I2 is how much? That is I1 cos square theta. So I write here I1 cos square theta sine square theta. Now place I1. I1 is I naught by 2. So this will be I naught by 2. ठीक है? And this is cos square theta sine square theta. Now what you do? Multiply numerator and denominator by 4. So I will write it as I naught by 8 and 4 here. So I can write it as 2 times cos theta sine theta and whole. This will be 8 here. 4 was already there. 2 was already there. I multiplied numerator and denominator by 4. So it will be 8 and 4 will be numerator. What is this? This is sine square. This is sine square 2 theta. I naught by 8. This is sine 2 theta. Square is here. So this will be sine square 2 theta. Okay. Now I3. I again multiply numerator and denominator by 2. So this will be I naught by 8, I naught by 16 and here it will be 2 sine square 2 theta. Sine square 2 theta. It is. Okay. Now here I will use this formula. Cos of theta, that will be 1 minus 2 sine square theta by 2. This is the formula. So if I make here 4 theta, try to understand, if you replace this by 4 theta, then this will be 1 minus 2 sine square 4 theta by 2, that will be 2 theta here. आधा होगा इसका, half of this will be here. So that is 2 theta. So this 2 sine square 2 theta, it will be 1 minus cos 4 theta. So I will write here 1 minus cos 4 theta. 1 minus cos 4 theta. And that will be the intensity I3. This is I3. ठीक है, तो ये कितना है? This is I3. Is it okay?
Yes, sir.
Now go to double refraction. Double refraction. So first question is, what is the meaning of double refraction? ठीक है, first we want to know what is the meaning by double refraction. We are aware about refraction. In case of ordinary light, try to understand, if you are having an interface between two mediums. Here first medium is N1, second medium is N2. If a light is incident on it, then a part of it will be reflected back in the same medium and a part of it will be refracted. So for one incident ray here, okay, this is called as angle of incidence, this is called as angle of refraction. So here for one incident ray, there will be one refracted ray. For one incident ray, there will be one refracted ray. This is ordinary simple refraction. Now, what is this double refraction? In case of double refraction, actually what happens, there are some crystals like calcite, quartz, ठीक है, there tourmaline is also there, topaz is there. They are known as doubly refracting crystal. What they have, they are anisotropic mediums. What they are having, they are actually anisotropic. They are anisotropic mediums. What is the medium? What is the meaning of anisotropic mediums here? What is the property of these? The property is they are having different refractive indices in different directions. So if you choose a different direction, you will observe a different refractive index. If you choose second direction, you will observe different refractive index. So why you are calling them anisotropic medium? Because they exhibit, yeah, they are having different refractive indices, different refractive indices in different directions. In different directions. Okay. So there are few crystals like calcite is one of them, quartz is there, tourmaline. Tourmaline is another crystal. Okay. There is topaz is another crystal. So there are many crystals which are actually anisotropic medium. We are calling them anisotropic because they are exhibiting different refractive indices in different directions. Okay. What they do, actually, if you choose a calcite crystal, for example, what happens if you are choosing a calcite crystal here, suppose this is a calcite crystal and a light is incident on it. What happens? A light is incident on it, or Just I make this a little bit much better. Topaz is here. So if I'm having a calcite crystal, this is just an example. A light is incident like this. Then what you are going to observe that here for one incident light, in this medium you will find out that there will be two refracted rays. For one incident ray, for one incident ray or light, you will observe that there will be two refracted rays. So here, when they will emerge, they will move like this. Okay? And both will be plane polarized. Here, both will be plane polarized. This is plane polarized light. This is plane polarized light. And this is incident light, or you can say this is unpolarized light. So when a unpolarized light is incident on these crystals, then you will find out that for one incident light, there will be two refracted lights, or there will be two refracted rays, and both will be plane polarized light. So this type of phenomena where for one incident light, okay, there will be two refracted rays, this phenomena is called as double refraction. Okay, this type of phenomena is known as double refraction. So what is double refraction? Double refraction is a phenomena where for one incident light, if it is incident on a medium like calcite and quartz, then for one incident light, there will be two refracted rays. There will be two refracted rays. And both the refracted rays, they will be plane polarized. So this phenomena is known as double refraction. And these crystals which are exhibiting this double refraction, they are known as doubly refracting crystals. What they are known as? They are known as doubly refracting crystals. Refracting crystals. Okay, they are known as doubly refracting crystals. So this will be. Later on, I will tell you that one of the rays will have electric vector like this. One of out of these two refracted rays, one will have electric vectors like this, and another will have perpendicular to these electric vectors. So this type of two plane polarized lights are observed. So this phenomena is known as double refraction, and this type of crystals, they are called as doubly refracting crystals. Now these doubly refracting crystals, they are of two types. These doubly refracting crystals, they are of two types. So if you look at doubly refracting crystals, refracting crystals, they are of two types. First is uniaxial crystals. Uniaxial crystals. Uniaxial crystals, and second are called as biaxial crystals. Biaxial crystals. On which basis you are classifying? It is on the basis of number of optic axis these crystals are having. So there is one new term which I am calling as optic axis. So I will explain you what is optic axis, but uniaxial crystals are those doubly refracting crystals which have which have one optic axis. One optic axis. I will explain you what is optic axis. So two type of doubly refracting crystals are there. Uniaxial crystals are those crystals which are having one optic axis. While biaxial crystal, there are other doubly refracting crystals which are having two optic axes. So they are called as biaxial crystals. They have two optic axes. two optic axes. ठीक है. If you want to write the example of this is calcite. Calcite crystal is there. Quartz is there. Tourmaline is there. So these are the examples of the uniaxial crystals. So uniaxial crystals are those crystals, ठीक है, which are having one optic axis. And biaxial doubly refracting crystals are having two optic axes. For example, here topaz. ठीक है. So here, according to your syllabus, we will confine ourselves to the uniaxial crystals. Here in these classes, I am going to discuss only these uniaxial crystals. If you will have any another course, okay, in future of nonlinear optics, then you are going to study this type of biaxial crystals also. But here we will confine ourselves to here to uniaxial crystals. So on the basis of optic axis, we have made this classification. Now next question is, what is optic axis? Next question is, what is optic axis? ठीक है. So actually question is, what is optic axis?
Previous slide.
Okay बेटा.
Yes, sir.
Okay बेटा. So next is optic axis. What is optic axis? So optic axis, remember this is a direction. You can write here. You can write here. लिखिए, optic axis is the direction. ठीक है. Optic axis is the direction. Optic axis is the direction along which both the refracted rays called ordinary ray, both the refracted rays called ordinary ray and extraordinary ray, ordinary ray and extraordinary ray travel with the same speed, travel with the same speed. So what is optic axis for a doubly refracting crystal? So in a doubly refracting crystal, optic axis is that direction along which, if both the refracting rays are moving, if both the ordinary ray and extraordinary ray, we call them, okay, if they are traveling along that particular direction, then remember that both will travel with the same speed. Both will travel with the same speed. In other directions other than optic axis, they will always have different speeds. So you can write in the next line, in other directions, O ray, ordinary ray, in other directions, O ray and extraordinary ray, E ray. In other directions, O ray and E ray, O ray and E ray travel with different speeds. Travel with different speeds. So this is the only direction. Optic axis, if we are talking about uniaxial crystals like calcite and quartz, then optic axis is the only direction along which both O ray and E ray, they will travel with the same speed. In other directions, O ray and E ray, they are going to have different speeds. Always remember this. They will have different speeds in other directions. In the next line, please write, any line parallel to the optic axis any line parallel to the optic axis will also act as an optic axis. Any line drawn parallel to the optic axis will also behave as optic axis. Any line drawn parallel to the optic axis will also behave like a optic axis. ठीक है? The reason is optic axis is not a particular line. Optic axis is a direction. Even you can write in the next line. Optic axis is not a line. Rather, it represents a direction. Optic axis is not a line. It is representing a direction. It is representing a direction. It is representing a direction. So now, if we are having, in case of calcite crystal, in case of calcite crystal, I'm making a rough diagram here. Try to understand. These angles will not be 90 degree. I will mention the so here try to understand. Here three faces are meeting here. Here there are three faces which are meeting at this end. ठीक है, and these three angles here they are looking like 90 degree, but they are not 90 degree. They are all three angles here. How you can do this? Consider this diagonal and press this crystal like this, and I'm saying they are all 102 degree. ठीक है, so I cannot draw that type of diagram. And these three angles here, all the three angles, they will be 72 degree. So this type of calcite crystal is there. In You can look into Google, ठीक है, what type of crystal, you can look at its structure. So here all the three angles, they will be 102 degree. ठीक है, they will be 10. So this is known as blunt corner. What we call it, where all the three faces they are making at this point they are making 102 degree angle, and we call it as blunt corner. So I just want to show you the what is the direction of calcite crystal or optic axis for the calcite crystal. So draw a line here. Now draw a line that is passing through this blunt corner and making equal angles with all the three faces. One face is upper one, another is one is back face. So a line passing through this blunt corner and making equal angles with all the three faces. It is observing three faces of this crystal. So this line is making equal angles with all the three faces, and it is passing through this blunt corner. So this is the direction of optic axis in case of calcite crystal. I just want to show you this. So if you draw any line parallel to this, if I draw a line parallel to this will also be an optic axis, because this is a direction. This crystal here, I have used here only one building block of the crystal. So many building blocks are there. Okay, so if you choose in this crystal which is made up of so many building blocks, so all these lines which are parallel to the optic axis, they are all behaving like a optic axis. So optic axis is a direction, not a line. Remember this. So what is the, if someone asks you, what is the optic axis for a doubly refracting crystal? So for a doubly refracting crystal, optic axis is that direction along which is the only direction along which both the refracted rays, ordinary ray and extraordinary ray, they travel with the same. They are going to travel with the same speed. ठीक है ना? They are going to travel with the same speed. So along optic axis, you can write along optic axis, optic axis, speed of ordinary ray will be equal to speed of extraordinary ray. So in this way, you define optic axis. So in case of calcite, in case of quartz, in case of tourmaline, particularly calcite and quartz, we will use, there will be one direction along which both O ray and E ray, they are traveling with the same speed. That is known as optic axis. One more term is associated with these crystals, that is called as principal section. That is called as principal section. Yes, beta, please.
Sir, can you explain it once again? How means what three faces are intersecting to make 102-degree, and how the diagonal is placed? You told I can't understand that point.
Actually, if you are having this type of crystal where all the angles are 90 degree, for example, you, if hypothetically you think there will be a diagonal here to here, ठीक है, body diagonal will be there. If you press the body diagonal, by pressing the body diagonal, try to imagine you have made this angle, all the three angles 102, then automatically these angles, they will automatically convert it into 72-degree. So this is a type of crystal. It is it is find out in the nature. Okay. If you do the Google, you will find out the exact structure of this crystal. So what
Sir,
I'm
why
telling
are
you,
pressing it along the diagonal?
oh, just that is a hypothetical way to explain you. Consider, if you consider this body diagonal, this is the body diagonal. Okay. If all these are, suppose this is a, all angles are 90, what you do? Try to press like this. Rhombohedron, I think that type of crystal, exact name I don't remember right now. So if you compress this along the diagonal, then these angles are going to increase. Okay? These angles, they are going to increase, and all these three angles, they will be 102-degree for this calcite crystal. ठीक है, and these angles, these angles, they will become 72. just just write in your mobile phone, ठीक है, please write the calcite structure of the calcite crystal. You will find out what type of structure is that. ठीक है. So I just want to show you where is the direction of the optic axis. So direction of optic axis in case of calcite crystal is a line that is passing through this blunt corner where all the three faces are meeting and the angles are 102. ठीक है, and this line is making equal angles with all the three faces. ठीक है, with all the three faces this line is making equal angles. So that is the direction of optic axis. This is optic axis. ठीक है, and if we draw any line parallel to this, they will also behave as optic axis. They are also going to behave. So if light is traveling, if O rays, suppose your light is incident, suppose light is incident along optic axis. Okay, so what I'm saying, if light is incident like this, then in that case, O ray and E ray, ठीक है ना, they will travel like this. Along the optic axis, they will travel with the same speed. ठीक है ना, they are going to travel with the same speed. It will be like this. So optic axis is the direction in which O ray and E ray, they are going to travel with the same speed. ठीक है, exact structure you can look into the diagram. So yes, beta, please.
Whether only the doubly refracting crystals have optic axis or all other crystals?
No, only these are doubly refracting crystals. In other crystals, ठीक है, which are not doubly refracting, you are going to have one reflected ray for one incident light. ठीक है ना, there will not be a question of ordinary and extraordinary. You will have only ordinary ray.
Okay,
You
sir.
will have only one refracted light, that is ordinary one. So
Okay.
this extraordinary one, this will come into the picture when you are having doubly refracting crystals.
Okay, sir.
Okay?
Sir, when the light passes through the optic axis, will E ray and O ray get separated or both are same,
I
sir?
will come to that, beta. ठीक है ना? Very sooner or later, I will explain this aspect. I will explain you everything. ठीक है? So it will be quite early and it will be difficult to explain at this point, but you can easily understand that when they are going to travel one behind the other, when they are going to travel along the same speed. So I will explain you. Next. Next is principal section. Next is principal section. So what is the meaning of principal section? Try to understand if this is my calcite crystal. Okay, this is just I'm using just this is just a crystal. Okay, don't consider here where is the blunt corner, not like this. And you are having a incident ray. So this is the propagation direction. So what is this line representing? This is representing the propagation direction of incident light. So this is unpolarized light. Okay, so this is the direction of this line is representing the direction of propagation vector for this incident light. After passing through this, it will split into two. One will be this, and another will be this. Another will be this. Okay, so you are getting two plane polarized light, and when they are emerging, they will emerge like this. Okay, one will be E ray. I will call it as E ray, and another will be O ray. O ray. So now what is the meaning of principal section? So principal section is a plane. Try to understand. Principal section is a plane which consists of, okay, which consists of optic axis. Okay, principal section is a plane which consists of optic axis, this incident light and these reflected lights. Suppose my somewhere, okay, suppose this is optic axis. It can be anywhere. It can be here. It may be here. Suppose this is optic axis. I'm saying this is optic axis. So consider this plane. Okay, this plane. Consider this plane. This is incident light. This is refracted ray. This is E ray. This is O ray. This is the propagation direction of E ray. This is the propagation direction of O ray. And this is the optic axis. They all lie in the same plane. They all lie in the same plane, and you call that plane. Okay, you call that plane as principal section. So for one incident light, there will be one principal section. So so for one incident light, there will be one principal section which consists of optic axis, okay, optic axis, in O ray and E ray. Okay, so this plane consists of ordinary ray, extraordinary ray, okay, incident light, and this will also have this optic axis. This will have this optic. So in this way, so this type of plane, it is known as principal section here. So what do you call this? You call it as principal section. Okay. So what is important here? Suppose this is here, this board is the principal section. So here I'm saying whatever you are observing here, this is principal section. This is principal section. Okay, this is principal section. Try to understand. Okay, and this principal section, okay, with respect to this principal section, I can differentiate in between O ray and E ray. So what is now ordinary ray or extraordinary ray? So now with the help of this principal section, I can differentiate in between these two. So E ray is that plane polarized light. E ray is a plane polarized light whose electric vectors lie in the principal section, lie parallel or in the principal section. So E ray is that refracted ray. E ray is that refracted ray whose electric vectors lie parallel to the principal section. They all lie in the principal section. So electric vectors of extraordinary light lies in the principal section, while ordinary ray is that refracted light for which electric vectors, these electric vectors, ठीक है ना, they are perpendicular to the, these electric vectors are perpendicular to the principal section. So here I am considering this board as the principal section. So in case of ordinary light, electric vectors are perpendicular to the principal section. And in case of extraordinary light, electric vectors lie they are in the principal section. They are parallel to the principal section. So this type of crystal, ठीक है ना, which are producing two refracted rays for one incident light, they are called as doubly refracting crystal. Both these lights, they will be plane polarized light. One is known as ordinary ray, another is known as extraordinary ray. Ordinary ray is that refracted light, that refracted plane polarized light whose electric vectors are perpendicular to the principal section. And E ray is that refracted plane polarized light whose electric vectors lie in the principal section. Now, what is principal section? Principal section is a plane which consists of this optic axis. ठीक है, optic axis will lie in the principal section, it will consist of the propagation direction of the incident light. Simple. Others will be there. Ordinary light will also propagate. It will also lie in the principal section. Extraordinary light will also lie in the. Both will be in principal section. Both will be in the principal section. So this is principal section, optic axis, ठीक है, and double refraction.
Sir,
Sir,
Yes, beta, please, बोलिए.
so
sir,
E ray, O ray, and optic axis always lie along same plane, sir.
Means oh, O ray. This O ray will be here, ठीक है. E ray will be here. So this is plane of incidence also. So here this plane of incidence is parallel to the, ठीक है ना. So here in this case plane of incidence is parallel to the principal section here. So in this case O ray, E ray, ठीक है ना, they are lying in the same plane. Here
सर
they are lying. Yes, beta, please.
सर हम कह सकते हैं कि प्लेन सेम होता है लेकिन डायरेक्शन अलग अलग होता है।
डायरेक्शंस अलग अलग होता है, ठीक है.
यस सर।
करेक्ट बेटा, ठीक है. डायरेक्शन ऑफ इलेक्ट्रिक वेक्टर्स आर डिफरेंट. डायरेक्शंस ऑफ इलेक्ट्रिक वेक्टर्स आर डिफरेंट, ठीक है. इट विल मूव इन another direction, it will move in the other direction. So this is the principal section, as well as here I am showing you the plane of incidence. So electric vector of ordinary lights, they are perpendicular to this principal section. Here they are parallel to the principal section. So
sir,
yes beta.
sir, why means for one type of means for particular unpolarized light there will be only one principal section?
Why, please?
Sir, you told that for one means for a particular unpolarized light there will be only one principal section, right? Sir,
Half,
why?
if you are launching the light from another direction, then corresponding to that there will be a principal section. If you change the incident light, direction of the incident light, automatically there will be another principal section which will consist of optic axis and the
Okay.
incident light. ठीक है? If you introduce the incident light from some another direction, then for that third direction there will be a plane which will consist of optic axis and the incident light. So in this way, for every incident light, depending upon which direction you are launching on the doubly refracting crystal, you will have a principal section. Is it clear what I am saying?
From,
Yes.
for a
It's not
doubly,
necessary that you are launching from here. You can launch from this side. You can launch from this side. You can launch from this side like this. In any direction you can launch. So corresponding to the launching direction, there will be an incident light. There is optic axis. The optic axis direction is fixed. So a plane consisting of incident light and the optic axis, whatever plane will be there, ठीक है ना, correspondingly there will be a principal section. ठीक? Is it clear?
Yes, sir.
Now, next question is ordinary and extraordinary ray. ठीक है? Ordinary light. So first is ordinary ray. So this is simple ray, ordinary ray. So ordinary ray is that ray which you are going to observe in other cases also. ठीक है? Which you are going to observe. So here you can write. Here you can write. लिखिए बेटा. Ordinary ray. Ordinary ray is the ray which obey laws of refraction. So ordinary ray obeys laws of refraction. ठीक है? Laws of refraction. Number 2, ordinary ray travels with the same speed in all the directions. The speed of ordinary ray will be same. It can move, it can travel in any of the direction in the doubly refracting medium. ठीक है? Its speed will be same. Speed of O ray, speed of O ray remains same. Remains same in all directions. So this is ordinary light. This is ordinary light. ठीक है ना? It obeys the laws of refraction. It have it have it travel with the same speed in it travel with the same speed in all possible directions. ठीक है? It lies in the plane of incidence. It lies in the plane of incidence. In the plane of incidence. ठीक है? It lies in the plane of incidence. ठीक है? This is third point. Please write all these points. Next, most important, electric vector of O ray is will be are always perpendicular to the principal section. To the principal section. Are always perpendicular to the principal section. ठीक है? So this is. Next is extraordinary ray. Next is, please write. Next is extraordinary ray or E ray. Extraordinary ray or you call it as E ray. ठीक है? E ray. So first, E ray doesn't obey the laws of refraction. Laws of refraction. Number 2. Number 2. E ray has different speeds, has different speeds in different directions, in different directions. Different directions. Number three, it is not necessary. Yeah, you can write here in journal, E-ray, in journal, E-ray, in journal, E-ray doesn't lie, in journal, E-ray doesn't lie in the plane of incidence. In journal, E-ray doesn't lie in the plane of incidence. In journal, E-ray doesn't lie in the plane of incidence. ठीक है? Doesn't lie in the plane of incidence. In the plane of incidence. Incidence. ठीक है? However, when plane of incidence plane of incidence is parallel to principal section, then E-ray lies in plane of incidence also. Plane of incidence also. Incidence also. Number 4, electric vector of E-ray lie in principal section. ठीक है? Lie parallel to the principal section or parallel to the are always parallel to the principal section. ठीक है? सो बेटा आज यहीं रुकते हैं, थोड़ा मुझे जल्दी छोड़ना है. ठीक है? चलिए बेटा, तो आप लोग एग्जाम दे रहे हैं ना? हेलो, ऑन संडे यू आर हैविंग एग्जाम?
Yes,
हेलो
sir.
एम? ठीक है बेटा, prepare for your exam and all the best. ठीक है, we will
Sir, can I
continue.
show the slides?
Yes, but I will show you all the slides. So after the exam, we will again start from here. I will explain you all the aspects of the polarization. So this is a little bit lengthy chapter. ठीक है? Double refraction will be there. Nicol prism is there. ठीक है? Nicol prism can act as analyzer as well as polarizer. Then with the help of Nicol prism, we will find out how we can produce linearly polarized light or plane polarized light, circularly polarized light, elliptically polarized light. Then how can we, if a unknown light is given, Then with the help of Nicole prism, how can we find out which polarization this light is having? We will discuss half wave plate, full wave plate. So we are going to discuss all these aspects. Please look into all the slides, save all these slides. This is the first one. Second, third, fourth, fifth.
Uh,
Yes, beta.
the principal section consists O ray, E ray, and optic axis, right?
Optic. Actually, very simply, even not go for O ray, E ray. This consists of, okay, you just can say incident light and the optic axis. Okay, incident light and the optic axis. So what you have to do, you will consider a plane that is passing through the optic axis and rotate it unless and until incident light is lying in it. Okay, when incident light will lying in it, okay, you are considering that plane as principal section for the propagation of light in the doubly refracting crystal. That is very simple. So we don't care from which direction light is incident. You have to consider a plane that is passing through this optic axis and rotate this plane which you are considering. And you are going to rotate that plane. You will try to find out that plane, okay, which also consists of incident light. So whatever plane that will be, ठीक है ना, that plane is known as principal section for studying the propagation of light here in the doubly refracting crystal.
Sir, one more doubt, sir.
Yes, but
Uh, as principal section has three rays, the ordinary rays always lies in the plane of incidence.
yes. But
Then
principal, what is the plane of incidence? Plane of incidence is, ठीक है, that consists of incident light and normal also. ठीक है? So that may be different. So incident light, normal, and refracted light. ठीक है? So that will be the plane of incidence. So that is a different. So these three here choices are different for plane of incidence. Plane of incidence, it's not necessary that that is going to consist of this optic axis. Okay? But when that plane of incidence also consists of this optic axis, then that will be parallel to the principal section. So plane of incidence, it consists of incident light, normal, and refracted light. So if you consider ordinary light, normal, and the incident light, okay, these three, they always lie in the same plane. So ordinary light that is behaving like a ordinary one, so it will always lie in that plane of incidence. But this E ray, that's not necessary. But when you are considering principal section, you are going to choose first that plane should pass through optic axis. First condition is this, and then you will rotate it. Okay, then you are going to rotate it up to the point when optic axis is there. Then you will find out a plane, okay, na, that is passing through the incident light, this optic axis, okay, and you will find out that two other rays, they are in that plane also. That is known as principal section. However, for ordinary light and extraordinary light, they are traveling in different directions. Their directions are different. So if you want to find out the angle of refraction for extraordinary light, it will be like this. This is air, refractive index of air, and this is incident angle of incidence, okay, from outside when you are launching. Now here you are having two refracted lights. So in a particular direction in which E ray is moving, so refractive index in that direction, in that particular direction, and this will be sine Sine you can say theta e. This is angle of, yeah, RE लिख सकते हैं. We can write it as angle of refraction for extraordinary light. And for ordinary light, Na, sin I, this will remain same, but refractive index for ordinary light, that is different. So this will be sin RO. So directions are different, but they will be in the same plane, that is principal section. ठीक है बेटा.
Thank you,
चलिए बेटा,
sir.
यहाँ से वेलकम बेटा. So I think I have shown you all the slides. So this is the fifth one. Sixth one is this. This is sixth one. Seventh one. And this will be eighth. ठीक है. Okay बेटा. Thank you very much.
Thank you, sir.
Welcome बेटा.